get into these notes and wrap these up, just kind of revisiting what we talked about yesterday. We ended on this. You guys were pretty familiar with the x-axis, y-axis. You told me what the quadrants were. I think Travis then told us that there was in the first quadrant, it was a positive, meaning both the x and y's are positive values. Second quadrant, the x is negative, the y is positive. Third, it's negative. And the fourth quadrant, x is positive, y is negative. We talked about that yesterday. Does anybody have questions on that? The one thing I want to talk about, and it does get confusing a little bit because of the labeling of these axes and what we're talking about here, but there's no way around it. We call this the x-axis, but we identify it equation-wise as y equals 0, right? So a lot of people get confused because it says x-axis and they think they should say x equals 0. I need you to understand that they're not the same, x-axis and then y equals 0. But I want to show you the logic of why we say it's y equals 0, okay? If I were to graph a point on that axis, okay, so this blue point, okay, is right now on the x-axis, right? And you see as I move it around here, and let's actually, might be easier to, so I don't have to keep looking back here. There we go, name and value. All right, so if I slide this point around, it's going to continually give me that ordered pair, right? No matter where that point is. So right now we're at 8, 0, right? And keep going, 10, 0, okay? But no matter where I put point B, what is the y value? 0, okay? So y is always 0 for a point that is on that axis, right? So that's the logic of why we say y is equals means is, right? So y is 0 for any point that is on the x-axis. Okay? So if we understand that, then that hopefully then allows us to understand this one. If it's the y-axis, then that says that every point that I graph on the y-axis, the x value is 0. Okay, so let's demonstrate that. Okay, so you see point A here, no matter where I slide it, that x value never deviates from 0, right? It is always 100% of the time the value 0. So that's the logic of why we say the y-axis is renamed and as an equation as the line x equals 0, because any ordered pair on it has an x value of 0. Does that make sense? Okay. And I'm a fan of learning things that way. I'm not a fan of remembering, the horizontal, just forcing my memory to say the horizontal one is y equals 0. I want to know why it's y equals 0. What is the relationship that says or that establishes that fact? Okay, because your memory will fail you, right? Have you ever tried to memorize something and then come to class and you got quiz or test over that, and what you memorize, you either get it jumbled up or you totally forget it? That anxiety, that test anxiety, a lot of times makes us forget things that we've crammed for, things that we've tried to memorize. So in mathematics, I try to minimize that. I try to eliminate all memorization because it will fail. My memory will fail me at some point in my life. Okay, no matter what, you try to memorize something, you might remember it for a day, you might remember it for a week, you might remember it for a decade, but eventually your memory is going to fade and you're going to forget it. Regardless of the time between you learned it and when it fades, it will fade. Does that make sense? But if I can learn the relationships, if I understand that concept that we just talked about, I'm not now memorizing y-axis is x equals 0. I know why the y-axis is written as x equals 0. Okay? So you're going to hear me talk about memorization and that kind of thing kind of all year long. In the last class, kind of demonstrated that you guys have quite a bit of exposure to this in regards to graphing points, but I just want to make sure that we're all on the same page, that we all understand how to do this, because as we work through the algebra for the rest of the year, this is the backbone of it. Okay? Every time we solve an equation, every time we graph a line, every time that we solve two equations together at the same time, there is a graphical backbone to it, meaning that there's something behind the scenes that we're doing. Maybe we're doing it by hand. We're solving an equation by hand. There's a graphical aspect that we can address. So I want to make sure that we understand the basics of how we graph points. All right, so the first thing here we're going to do is look at the fact that all of these points are written in terms of an x comma a y, right? So this is my x, and this is my y. Okay? Now, as we start plotting points, we always start from the origin. We always start there at 0, 0, right? We're always going to come back. That's our reference point. Okay? Meaning that's where you always begin. Okay? That's what's called the origin. That's the original or the initial position. The x tells me to move left or right, correct? So if it's positive, I move which direction? Right. So I'm going to move 3 units to the right. Just be careful with how your x-axis is set up. Sometimes your x-axis maybe every vertical line doesn't maybe represent one whole thing. Maybe this represents a half and then 1 and then 1.5 and then 2. So you might have to go 6. Does that make sense? But the way this one's set up, I just got to move over 3 vertical lines. Okay, so I'm right here. That's at an x value of 3. Now where do I need to go? Down. How many? Okay, so down 4. All right. So that point right there is point A. This is what I'm always going to do, is label that point. Okay. A lot of times people, when they graph something, they just graph the dot, okay, or the point, and they don't label it. And then later on, they need the information from that point, so then they got to go back and count the steps that took them to get from the origin to that point. Or if I label it like this, and later on I need to know that the y value is -4, I don't have to look at the graph or anything. I don't have to do any counting. I just look at the label that I have there. So labeling everything is very, very important. Yes? You can. That's not terrible. But then I'd still have to eventually then reference back to this to see what A's order pair was or to count. I would prefer this. Eventually there might be aspects where it gets too cluttered and we do just put the capital A. If I'm going to do the next one, I'm going to do B. So again, start back at 0, 0, right? Always start back at the beginning. Now where am I going to go? Right 2, and then where? Up 5, good. So it's point B, 2, 5. If we do C, what quadrant is C going to be in? Lindsay? 3rd quadrant, good, okay? So we're going to go left 5, and then down 7, right? And D is going to be in the 2nd quadrant. Start at 0, 0, left 3, and up 5, right? Is everybody okay with those? Last class shared with me that they've done this. They feel comfortable graphing points. I always want to make sure, because every time that I've done something with a class and made the statement that, we've seen this before, we're comfortable, inevitably somebody will come and say, I don't know how to graph points, or I don't know how to do this that you've assumed that we did know how to do. Okay, so if at any time we're confused, just let me know. Now I want to do the remaining points here, and they're a little bit different. Okay, notice these all incorporate a 0, right? Okay, so I'm going to plot E at 6, 0. So the 6 tells me to move to the right. Good. Now the 0 tells me move up 0 or move down 0, which means don't go anywhere in the y direction, right? So I'm just going to plot that point right there. And that becomes then E, which is 6, 0. Now, my question is going to be, what quadrant is that in?
1.
Is it? Because if your argument is 1, then I'm going to have the exact, however you tell me that you know it's in 1, I'm going to use the exact same argument to tell you that it's in 4.
It's in both.
Okay, so if I am standing on the fence between my house and my neighbor's house, right down our property line, or if I'm standing on the border of Ohio and Indiana, or Canada and United States, am I in both countries?
Yes.
No, I'm not. I'm in neither.
Ah.
Okay, so whenever we're on an axis, we're not considered to be in either quadrant. Okay, we're not going to use this very often, but they sometimes will call that a quadrantal point, meaning that's on the barrier or the breaking point between two quadrants. Okay. What about 0, 5? Where do I go from there? Starting at 0, 0, where do I go?
Up 5.
Up 5, good. So 0, and then Y is a positive 5, so that's going to be F. G is going to be left 4. Left 4, and then up 0 or down 0. And then 0, negative 7. And the biggest mistake that I see, and I even do this from time to time, is that when I get like negative 4, 0, I'll accidentally graph that on the y-axis. Okay, people flip-flop the order pairs sometimes, or the order that you graph in left, right, or up and down. So just be careful with that. But does anybody have questions on how to graph those points? Is that something we can do? Okay. Quadrantal, Q U A D R A N T A L. R-A-N-T points.
Oh.
Which I'm not going to use ever on a test or quiz ask you that vocabulary word. But that is usually how textbooks will refer to it. All right, so now that we know how we revisited that, we got back in the mode of plotting points. Now let's actually apply it and see where plotting points becomes useful to us. Okay. Now these questions are not all that difficult in regards to the relationship between the things that we're putting in into the equations or into the ordered pairs here. But if we can get this understanding and this kind of structure understood, then when we can make the relationships a little bit more difficult, it shouldn't be a very hard task. So the question says Steve and Claire share the same birthday. So these two people born on the exact same day. Okay? But Steve is 2 years older than Claire. All right? So we want to represent this idea in a table. And I structured this to kind of start off with Claire's age being at 0. Okay? So the instant Claire is born, how old is Steve? Steve's 2, right? Okay? Now, I'm going to, just kind of doing what I did in the last class, let's just go to Claire's first birthday here. I could skip to her second birthday or third birthday or fourth birthday, okay? But I'm just going to go to her first birthday. So if it's Claire's first birthday, it's Steve's what birthday? Third birthday, right? So we got a 3 here. If Claire turns 2, Steve turns 4. Claire turns 3, Steve turns 5, right? Claire's 4, Steve is. So we're all getting the idea that I'm just adding 2, right? Oh. Is that something we can do? All right. Now, like I said, I could have maybe just done something like this where, see if this will work. Like I could have started at Claire being 1 and then jump to her being 3, and then jump to her being 5. Does that make sense? So I could have done that. Still gives me those relationships, right? I can still find out Steve's age. I could do something like, let's start Claire at 2, then when she's 4, and now 5, 6, and then 8, okay? But do you see how from 2 to 4 I jumped 2 years, and then 4 to 5 is 1 year, 5 to 6 is 1 year, and then 6 to 8 I jump again 2 years? What we usually want to do when we're trying to develop a relationship amongst two ideas, or in this case, two people's ages, we want them to be kind of systematic. We want a progression in Claire's age to be the same from kind of box to box. Does that make sense? You could do any of those, yes. Say again? Okay, so you jumped, so you went, so you could have gone with just these. So you did? Jump 2 years? That's fine. Okay? But regardless of how you do it, what you want is the fact that between these two, large, between, we call these data points, but between those two data points, there's a 2-year gap, right, between Claire's age. Here we want a 2-year gap. Here we want the same 2-year gap. Here we want the same 2-year gap. Does that make sense? Because if I can see that there's a 2-year gap there, then there's a 2-year gap there, there's a 2-year gap there, 2-year gap there. If these gaps are the same across the top, and they're then the same across the bottom. Now, it doesn't have to be that one and that one being the same number. This could have been a 3 and a 3 and a 3, or a 5 and a 5 and a 5. You see on the board I have up there another example that we did in the last class. So let me draw that real quick. If I've got, let's just say we start at 0 and go to 4, and then 8, and then 12, and then 16. You see I've got from point to point, we're increasing by 4 here, right? Increasing by 4? Go ahead. Down here, we've got, let's say I've got 3, 6, 9, 12, and 15, correct? Up here, it was a jump of 4, 4, 4, 4. Down here, it's 3, 3, 3, 3, right? But if we see that consistency in those rows, that tells us that this graph is going to be a line. Does that make sense? Okay? Which is what we're going to try to get to when we plot these points. Okay? So this information right here, when Claire is 0 and Steve is 2, I'm going to take that information and I'm going to write it as an ordered pair. Claire is 0, Steve is 2. Okay? So all these ordered pairs down here, they follow a form of x comma y. But the x is Claire's age, and the y is Steve's age. Okay? Now, if you wanted to, you could flip-flop that, and you could say, well, I'm going to let Steve's age be x, and Claire's age be y. That's fine. Okay, just the way this one's set up where it says Claire first, let's let Claire's age be x and then Steve's age be y. Is that okay? Okay. So if I got 0, 2 is one ordered pair, then 1, 3 is going to be another ordered pair. 2, 4, another ordered pair. 3, 5, another one. Okay, see the pattern here, right? 4, 6, 5, 7, 6, 8, 7, 9, 8, 10. And most of the time we don't need that many, so we won't, I don't know how many I've got up there, 9 or 8 or something like that. You don't need that many eventually. Okay, 3 or 4 will be fine. But that's how we gain ordered pairs from a table. Okay. It is important though when we write that data. So I write 0, 2 or 1, 3, and I just see it as 1, 3. I need something to tell me what does the 1 represent? What does the 3 represent, right? So that's why I've got that up there in the top says Claire's age is the 1, Steve's age is the 3. Is that okay with everybody? All right. So now that's interpreting a table and converting things into ordered pairs, or what I like to call data points. Okay. The next step is to represent it graphically. Okay. So we got a bunch of ordered pairs here, right? And what we just talked about in graphing points, we should be able to do. Let's go. We got the first point, 0, 2. Now I've drawn parts of all 4 quadrants, but because age is always going to be a positive number, right? I don't need the 4th quadrant. I don't need the 3rd quadrant. I don't need the 2nd quadrant. So mostly just the first quadrant here. But 0, 2. So I'm going to start at 0, 0. I move 0 in the X direction, 2 in the Y direction. So that's that first point. Now here, kind of going off of Devin's question a little bit ago, do I have to put I don't have a label here for 0, 2, right? So just leave it alone. Don't put anything there. And we're going to see here as it get really cluttered if I start putting all the labels in here and all the names or coordinates for these points. So I'm just going to plot 0, 2. Then 1, 3. So start at 0, 0, go over 1. And then up 3, right? 2, 4. Start at 0, 0 again. Go over 2. Up 4. 3, 5. Start at 0, 0. Go over 3. Up 5. And you can do that again for all of these. But once we start seeing a pattern here, that pattern is going to be maintained all the way through. So if I go 8, we'll finish at 10, right? You guys remember? Did you guys do any of this last year? Okay, so now I'm going to connect those. Oh, let me use... Well, this is supposed to work a little bit better than this. There we go. All right, so we get that line, right? Now, the benefit of that line, guys, is that we should be able to extend that forever. We should be able to keep drawing that beyond the points that I've graphed, right? And what that would allow me to do is say, okay, even though we don't have the data point for when X is 12, when Claire is 12 years old, if we extend that graph, okay, keep pulling that in this direction, and I want to know when Claire is 12, so I'm going to go find the line of where Claire was 12, and we'll trace that up, and it's going to hit right there, and then work my way over. Will that tell me how old Steve is?
14.
Steve would be 14. Does that make sense? So that's the benefit of being able to graph data points and then extend the line to project future data points. Okay? Now, that's awesome. That's great. But what if I ask you, well, what if Claire is 38? Well, then I have my graph go out to 38, right? Okay? So there's a better way. There's a way to get those larger values, and that's to write an equation. Okay? So I'm going to come over here. It says now we're going to write an equation for this situation. All right? And there's some information there, but basically it says that every equation we write is going to be terms of x's and y's. Okay? An equation is basically a rule that will solve for y. It will tell you what y is when you choose a value of x. Okay? So here's what I want you guys to understand. We've got two people's names here, right? We got Steve and Claire, correct? Okay? And the statement said Steve is 2 years older than Claire. Okay? If I read that, who does that tell me the most information about? Or who is that statement saying the most about it? It's saying the most about Steve, right? All the information about Steve, okay? Guys, heads up off your desk, okay? I'm not going to fall asleep on you. You don't fall asleep on me. Heads up off your desk. Heads up off your desk! Okay, so Steve is 2 years older than Claire, right? Okay? We know nothing about Claire, so this is what you do, okay? Claire is going to be your simplest variable. You let it be X. Okay? At all times, no matter what, and this is something that I tell all my classes because we deal with this at every level of math from here on out. When they give you a phrase and you have to write your variables, you have to create an equation or something like that, okay, you have to read it and think about the statement and think about who they are telling you the most about and who they're telling you the least about. Okay, like Annika told us, they're telling us the least about Claire, so we let that be the simplest variable we can come up with, which is just X. Okay? Now, Steve would be what? Now think about this, 2 years older than, remember, about a week ago. Now, older than would be like more than, right? Okay, so X plus 2, okay? So this is a practice of applying what we already learned 2 weeks ago, right? Okay, and working with those English phrases and change them to algebra. So 2 years older than would be X plus 2. Now, some of you might write it as 2 plus X. Is that the same thing? Yes. Okay? Now, when we do that, okay, we have to think about what is our most complex thing up there. It's Steve's age, right? So what we're going to do is we're going to let Y end up being equal to that more complex thing. Y equal X plus 2. And again, that should mimic what we did with the graph here. Remember the graph, we said the X values, as we worked up here, Claire's age was your X value, right? Here, your Y value was Steve's age, right? So shouldn't here your Y value equal Steve's age as well? Does that make sense? And we have defined Steve's age as being X plus 2. So your Y value has to equal Steve's age. Okay? Now, here, and I think that's the hardest part. I think that is very difficult a lot of times until we see more and more and more and practice that. That might be a hard thing to do for people. But you should always, once you have an equation that you think is valid, you should always be able to check it using your ordered pairs. So we had some ordered pairs like 0, 2. We had one of 1, 3. I'll do, what do we have, one of 6, 8. If my equation works, if my equation is true, then all of those points, 0, 2, 1, 3, 6, 8, and all the other ones that we had up there, should fit into that equation and give me a true statement. You guys remember doing the problems where it said, if you have like 3m plus 2n minus r, to evaluate that, if m is 2, n is 3, r is 5. Remember doing that? Okay, about a week and a half ago. This is the same thing. This is x, and that's y. This is x, and that's y. This is x, and that's y. Let's take those things and plug them in here. If y is 2 and x is 0, does 2 equal 0 plus 2? That's a true statement. So far, now we need to check more than one point, but so far that's telling me my equation that I came up with does produce one of the data points that we know was right when we made our table, right? Okay, let's try the 1, 3. Let's see if that one works. I plug in the 3 for y. Plug in the 1 for x. Does 3 equal 1 plus 2? Yeah. So again, that's more support that our equation is right. We'll do one more. Plug in y to be 8. And I get 6 plus 2 then, when x is 6. And again, that is a true statement, right? Generally speaking, the more points that you check and the more times that you get true, the more confidence that you can, or the more you can be confident that your equation is correct. If any of those were false, if I got like 6 of those to be true and 1 of them be false, that means that my equation does not mimic the data that is being provided in the ordered pairs of the table. Okay? Does that make sense to everybody? Now, the benefit of the equation over anything else, says, well, what if y equals x plus 2? Remember, x was Claire's age. What if Claire is 42 years old? And can I put 42 in for Claire's age? And does that automatically then tell me that Steve is 44? Does that make sense? Or, what if it says Steve is 50? If Steve's 50, which was y, right? Can you solve that for x? What do I need to do to solve that for x? All right, careful. Subtract 2 from both sides, right? And that would tell me x is 48, so Claire would be 48. So that's the nice thing about an equation, is that it can predict or give me accurate values for larger inputs of x and y. Does that kind of make sense to everybody? I want you guys, so there's another one there talking about these 2 people running laps. So I want you guys to start this, okay? It says Will runs 4 laps around a track. Megan joins after his 4th lap. They continue to complete lap after lap. It says express the relationship between Will and Megan's number of laps in tabular form, graphical form, and an equation. So make your table. Okay, and here I'm only asking you to do 5 points. Then write your ordered pairs from that, graph them, and then write an equation. Before we do it, how do you guys want to do it? So everybody's on the same page. Do you want your ordered pairs to be Will, Megan, or do you want them to be Megan, Will? I think most people, the way I've set this up, and I probably should have thought about this a little bit better, but I think the way it's set up is that most people would write them as Will, Megan. Okay, just because Will comes first, Megan comes second, right? Okay. Give that a shot. That is fine. If you had something different, maybe you had something like this. Maybe you had, if I started at, erase all of them. I could have started at 7. If Will has 7 laps in, but Megan didn't join him until after his 4th lap, then at that time she only has 3 laps in, right? Does that make sense? And then you can go 8, and then she has 4, and he has 9, he has 5. What about this? Let's say, if Will has 0 laps in, isn't Megan 4 behind him? Could you do that? And if Will has 1 lap in, now Megan is 3 behind him. He has 2 in, she's 2 behind him. Or sorry, I guess 2 behind 0, so still 4 behind him. 3 in, she's at -1 lap. If he has 4 in, she's at 0. If he has 5 in, she's at 1, right? So where you start doesn't really matter. It's the fact that you still have the relationship that she is 4 laps behind him. Okay? Now I'm going to go with the original list that we had there where we're starting with 4, going to 5, 6, 7, 8 for him. Okay? So now the ordered pairs, do you guys agree they'd be 4, 0, 5, 1, 6, 2, 7, 3, and 8, 4. Okay? But if you started at 5, and you had 5, 1, 6, 2, 7, 3, 8, 4, your next one would be 9, 5, right? And that's fine. Okay? Your data still mimics most of mine, and the lines that we both draw are still going to be the same. Okay? Everybody okay with that idea? Now I want to graph those points. So I'm going 4, 0. So X is 4, which is Will's laps, and Y is Megan's laps. So Will goes 4, Megan goes 0, right? If Will goes 5, she goes 1. Will goes 6, she goes 2. Will's at 7, she's at 3. Will's at 8, she's at 4, right? And we could, connect those with the line as well. So now we want to write an equation. This was a little bit different. Okay, writing an equation. Remember, our equation is always y equals. Well, remember, y was what Megan's laps were, right? Okay, y was Megan's laps. So we want to be able to write an equation that tells me how many laps Megan has ran based off of how many Will has ran. Annika? Okay, so if I go 4 plus 0, okay, let's see here, 4x plus 0. Now let's see if this will work. Let's see if I plug in I plug in that x value and that y value, do I get a true statement? So is 0 equal to 4 times the x of 4 plus 0? Does that end up being a true statement? No. So 4x plus 0 is not it, but try something else. He has 4 more than him, right? Or sorry, he has 4 more than her. Close. Okay, so let's go x minus 4. If I go x minus 4, okay, plug in that x and that y. So I get 0 here, 4 minus 4. Is that a true statement? So that one works. Let's see if it gives me 5 and 1. See if that one works. If I plug in 1 and go 5 minus 4. Yeah, is that a true statement? So that one works. Okay? So x minus 4 is the correct equation. We'll work more on this tonight or tomorrow. There is a homework assignment open you guys can start on. And then we'll finish up these things tomorrow. See ya. Have a good one.